Alright, David again here with another question from the question bank in the style of what you find in Chapter 3H.2 of your Hayes and Harris Math SL textbook. In this question, we're dealing with exponential decay. We have a tank containing 10,000 liters of liquid, I'll call it water, at time 0. A tap is opened, time is measured in minutes, and liquid flows out of the tank. The volume of liquid in liters, which remains in the tank after t minutes, is given by this equation. So we have some sort of tank of water. And it's got a volume V in it. But we open up a tap, and the water's coming out at some rate. We want to find the value for V after 5 minutes. So we're going to let t be equal to 5, because t is in minutes. So V is equal to 10,000 times 0.933 to the power of 5. That's not something you'd be expected to do in your head, so we'll use your calculator. And we'll calculate 10,000 times 0.933 to the power of 5. And we get that there's just over 7,000 liters remaining. To 3 significant figures, this is going to be 7,007D. Liters. Part B, find how long to the nearest second it takes for half of the initial amount of liquid to flow out of the tank. So the initial amount is 10,000, so half would be 5,000. That means we want 5,000 liters to be remaining from our original 10,000 multiplied by 0.933 to the power of t. So how long t? We can use logarithms to solve this, but we've got our calculator, so let's make life easy. Let's use nsolve. We're going to nsolve the equation 5,000 equals 10,000 times 0.933 to the power of t. The variable that we're solving for is t. What do you got, calculator? All right. 9 minutes. 9.9949 minutes. Which means that to the nearest second, we have 9.9949 minutes. Well, that was mean. To the nearest second, so we need to find out how many seconds is 0.9949 of a minute. This is going to have to be 10 minutes, 0 seconds. All right. Okay, like 99.5% of a minute is a whole minute to the nearest second. Part C, the tank is regarded as effectively empty when 95% of it has emptied. We want to show that this takes almost 3/4 of an hour for this to happen. Why do they make me work in hours? Should be just minutes. Oh, I gotta work in hours. Okay. If it's 95% empty, that means it's 5% full. 5% of 10,000 is 500. So we have 10,000 times 5%. That's 10,000 times 0.05. That's 500 liters. So we want to find how long it takes for 500 liters to remain. So 500 liters is equal to the initial amount, 10,000 liters, times 0.933 to the power of t. How long does that take? Well, again, let's use our calculator. Let's make life easy. We can continue to make life easy by just modifying the equation we made before. We don't want it to be 5,000, we want 500. Solve for t. It takes 43.2 minutes. Sure, that takes almost 3/4 of an hour for this to happen. 3/4 of an hour is not roughly equal to, exactly equal to 45 minutes. 43.2 minutes, therefore, is roughly equal to 3/4 of an hour. So it takes just less than 3/4 of an hour for the tank to be effectively empty. Part D, find the value of 10,000 take V when t is 0.001 minutes. 10,000 take V is the amount which has flowed out of the tank. V represents the amount in the tank. 10,000 is the original amount. So 10,000 take what remains is what has left. So 10,000 take V is equal to 10,000 take V, which is 10,000 times 0.933 to the power of t. But we're going to let t be equal to 0.001 minutes. So that's 10,000 take 10,000, 0.933 to the power of 0.001. And once again, we'll get our calculator to do the hard work for us. We've already entered most of this equation, so we'll grab that. And we're going to enter 10,000 take 10,000 times 0.933 to the power of 0.001. All right, we get 0.693. So the amount remaining after 10 minutes, or the amount that's flowed out, is 693 liters out. So we've lost 0.693 liters from this container. Now it says, estimate the initial flow rate of the liquid. Give your answers in liters per minute, correct to two significant figures. So we want to know how many liters per minute are leaking out of this tank. This is the change in volume with time. The change in volume that has occurred is 0.693 liters. And the time that it's taken is 0.001 minutes. We'll punch that in the calculator. Let's grab that answer, divide it by 0.001 minutes. We get 693 to two significant figures is 690 liters per minute.